met these a while ago, and not everyone remembers them. And it's often a situation where you don't necessarily need to, especially if they've got a diagram, but they might not have a diagram, so you do need to recognize how many sides they have. So a polygon is the general name for any closed shape with straight sides. Okay, so it has to be a closed shape with straight sides to be a polygon. So the poly means many, so that's why that's the general name. Okay, then each individual shape is named depending on how many sides it has. Okay, so one additional information that you need to know is if the word has a regular, it has regular it means that all of the sides are equal. Okay, so not all shapes or polygons have to have equal length sides. All the ones I've drawn do, just because that's the pictures that come up in Smart. So all the ones that you've got in front of you are regular shapes, but they don't have to be. Okay. But if they are regular, it means that all the sides are equal. And if all the sides are equal, it also means all of their angles are equal. So, names of them. Three sides. What's a three-sided shape? Triangle. Triangle.
I wrote a triangle one.
Okay, what's a four-sided shape?
Quadrilateral.
Quadrilateral. What's a five-sided shape? Six sides. Hexagon. What's the seven sides?
Hexagon.
All right, so it is a hexagon. No, hexagon. So there you go, it's hexagon, but that's no. Yeah, let's get it. Okay, eight sides. On the other side, this is a decagon is 10. Decagon. Oh.
Miss Harrison, did you know that?
Alright, interior angles of a polygon. Okay, so this is what we were talking about a minute ago, about the interior angles of a polygon. Now, we could have done a nice fancy investigation, but you probably or may well have done that in previous years, and I didn't want to spend so long doing it. I'm sorry, you haven't done it in the past. And just to make sure you're aware of what an interior versus an exterior angle is, the interior angles are the ones inside the shape, okay? That hopefully should be a given. The exterior ones are not. People think that this is my shape, this is my exterior angle, but that's not the situation. So my exterior angle is where if we had extended the lines of each of my sides of my shape, and note I've extended them all in the same direction. So these are all extended in a clockwise direction. Do you see what I mean? So it's not that I've done that one that way. Okay? So they're all extended in the same direction. These would be classed as my exterior angles. Okay? So my interior ones are inside, my exterior ones are outside.
On this paper it says external, so would this have
Oh, external, it's a neat different grading. External or exterior.
Did you say neat different grading?
Oh, I don't think that has a name. We would just know that this one plus this one will add up to 360. It is a reflex angle, but I don't know if it has specific like interior exterior. If that's just the fact that that's the side. But yeah, you are right. To investigate, we could cut up each one into triangles, but I'm afraid we're not going to. So let's go back and look at So it says in our sheet, number of sides. So number of sides was 3. Number of triangles is 1. So let's fill up these. Okay, because
The smallest number.
you have to do the smallest, fewest number.
You can make tons of triangles here.
Right, so this column here, we're going to be able to fill in 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so you can do that straight away.
Very good at that.
So here,
I wish you could make more shows like close
Yes.
and like 2 straight lines.
so my quadrilateral, remember we're trying to do as few triangles as possible, and they have to go from vertex to vertex. The smallest number is 2. Now whether you went that way or that way, okay, you can't do both, one or the other. So for this one we can make 2 triangles.
Should we draw this on actual thing?
If you want to. For your pentagon, how many can you make? 3. You're going to keep doing the rest of them, and we're going to hopefully see a second. Alright, so we should have filled in this diagram here, this chart. So we've got the number of triangles, the number of sides, number of triangles, and then the sum of the interior angles. Now, does anyone notice a pattern between the number of sides that the shape has and the number of triangles that it has? Tanya? It's always 2 less. Yes?
Or
Always
2
spot
more.
that?
The difference is 2.
So, the number of triangles is always 2 less than the number of sides. And then what did we say that we did with the number of triangles? We multiplied that by 180, yes? So, the formula we can use to find the sum of the interior angles of any polygon with n sides, so n is our number of sides, would be n take away 2 multiplied by 180. Okay? So this ideally is a formula or rule that you remember, but I wanted to talk about the number of triangles situation so that if in exam pressure you forget about it, then you can always see how many triangles you can cut it into. Okay, and then you just multiply that by 180. Hannah?
Can you please show me the hexagon with the lines through it?
I didn't draw all my lines.
So I have it, Hannah.
The hexagon would be here, here, and here.
180 and 1
Sure. Alright, so our rule for the sum, so this is the sum of the interior angles of any polygon. Okay, so that's how much those angles add up to. So what we can do on this one, when we're looking at that, the exterior angle, is we can fill in these 2 columns from that previous chart. Okay, so we're going to copy our previous chart, and then how we're going to find the angle or the size of each regular interior angle. How would we do it?
You divide by the amount of sides.
Yeah, actually I'll snap them.
Oh, sorry, I thought it was like a general question.
So, yes, so we would take our sum of our interior angles and you would divide it by the number of sides it has. Because remember we just said that regular polygons have equal sized interior angles. So you're going to have a go at that bad boy. Okay? Once you've found each interior angle, how are you going to find each exterior angle? What did we say about interior and exterior angles? They are always going to add to 180, yes? So you can find then your exterior angle for each of them by subtracting this number from 180. So I know that that's going to be 120. Okay, hang on a second. So that would be 120. Then how would I fill in this column? If I know that each regular exterior angle is 120, if I want to know the sum of the exterior angles for this shape, what would I do with this number here? Multiply by 3. Why 3? That's the number of sides stroke number of angles, yes? So I would then do 360 here. So you're going to fill in the rest of this chart. Okay? This 60, I did 180 divided by 3. Yeah, all right. It may be ruining it for some of you, it may not be. You should have found that this column was always 360. Alright, so now remember I did ask you to remember that you had rounded your answers, so when it comes to all of them, there should be 360 because you had rounded it. Okay?
What do you mean round? Because like
It's just a feature of any polygon. Okay? So when it comes to the sum of exterior angles, it doesn't matter how many sides the shape has got. The sum of the exterior angles is always going to be 360. Okay? So the sum of the exterior angles for any polygon is 360.